Hello, everybody, again. This is your instructor. I have a lot I want to cover this week. I want to wrap up the remaining part of chapter 3, which shouldn't take too long, and then briefly touch upon the beginning of chapter 4. So, the first thing I want to do is cover today is something that's called type conversion. Let me toggle back over here to our book and explain to you something that can happen, what typically happens within your program. So imagine that you have an operation. Okay, so you have an operator that takes two operands. Okay, what happens is your operands may be of different types, right? One might be an int and one might be a float. What's going to be the evaluation of that expression because you have two different data types? Well, based upon the C++ hierarchy, you will get a result based upon the what's called the data type ranking. Okay, and that's what this table is here. So the idea is that the primitive data types have a hierarchy or a ranking. Okay, at the very top is what's called a long double. To be honest with you, that's used very infrequently. And at the very bottom is the lowest ranking, which is just like our standard integer. And the idea is that what if we have an operation, right? So again, an operation is something that has two operands, and that operation is going to perform something on those two operands. So what if you have an integer multiplied times, right? So what if you have an integer multiplied times a float? Well, the evaluation of that expression or that operation will be a float because the int will be what's called promoted to a float. And it's basically how it works. So you don't need to memorize this table. You can just remember that the integer types have a lower ranking than the floating point types, and essentially the order goes int, long, float, and double. So let's take a look at a quick example here. Let me toggle back over here. So let's imagine I have, I don't know, I'll just create a simple operation. I'll do some multiplication or what have you. So let me create a local variable. I don't know, I'll just call this count. All right, and I'm going to assign it to a value 5, right? So there we have an integer. Let me create another local variable. This will be a float. I'll call this weight or something. And I'm going to assign that to value, I don't know, 7.2 or something. This is a float, okay? When you create a variable that's of type float, remember the literal, in this case here, the 7.2, that is actually going to be treated by the compiler as a double. Oftentimes your compiler will generate either a warning or perhaps even sometimes an error depending upon which compiler that you use, because it's going to try to convert that 7.2, which is a double, to a float, and you're going to you could get some type of loss of precision in your calculation. So the way that we can force 7.2 to be a float is that if we just append the lowercase, or you could even use an uppercase F after the numeric literal, that'll force 7.2 to be a float. It's just a little indicator to your compiler. Let's create one less variable. This is going to be double, and this will be the evaluation of the expression. Maybe I'll just call this product or something. Right, so product, we're going to multiply those two things together, and here I'm going to assign product the evaluation of the count times weight. Let me explain to you what's going to be happening here. So in this expression here, weight is a float which has a higher ranking than an integer, which is my count. Count will internally be converted to a float, which will multiply a float times a float. The evaluation of an expression will be a floating point variable. However, on the left side of my assignment operator, I have what I'm going to be assigning to is going to be a double. So the final evaluation of this expression here can be converted to something larger, which is going to be a double. And that's in summary, that's the gist of how data type conversion works in C and C++, and even in Java it works the same way too, in case you ever come across it. So just be aware that the general idea is, remember, little things become bigger when you multiply something together. It may become even larger, and that will be assigned to the appropriate data type. All right, the next thing I want to talk about is the concept of what's called a combined assignment. I skipped one or two sections in the book right now. One has to do with arithmetic underflow and overflow, and I think I actually covered that way back in one of the earlier lessons that we had. And the other one has to do with typecasting, which we're going to revisit a little bit later on. So here's the idea. You know, in programming, it is very common to repeat something over and over and over. All right, and the idea is that what we want to do is we want to make those types of tasks a bit easier. So there's a bunch of what are called compound operators, or more commonly referred to as combined assignment operators, which is something we can pull out of our toolbox to make some of our repetitive tasks a little bit simpler. So let me give you an example of what I'm talking about, and I'm going to show you another table that's within your book. So let's imagine I'm doing something where I have some kind of inventory management system, some online store, or what have you, and throughout the day, the quantity of some product in inventory is increasing or decreasing depending upon if I have more inventory coming in from a distributor or wholesaler or something. Then I have corresponding sales through my retail channels, which would reduce my inventory. Perhaps I get returns from customers, so that would go back into inventory, so that would be added into my inventory. So you get the idea, right? So the idea is that you have some kind of operation that you're going to repeat over and over again, and there's some shortcuts for us to do some of those things. So let's imagine I have a variable. I call it inventory. It's going to be a type int. All right, and inventory, and let's say it's assigned 500 units or what have you. And then let's imagine somebody purchases a quantity of something of, I don't know, let's say this is 10. And the idea is what we want to do is we then need to go ahead and update our inventory, because if we started off with a 500 and somebody purchase 10 of something, we obviously have 490 of that left. So what I could do is I could say inventory is equal to itself, right? Inventory, all right, minus the 10. Okay, that's short of the longhand, or what's called the verbose way to do this. All right, so what we would be doing is we would take in the value that's currently in inventory, subtracting it by 10, and then storing the result back into inventory. However, there's a shortcut, and what we can do is we can use what's called the compound or combined assignment operator, and it works like this. Oh, I'm sorry, I shouldn't say minus 10. I should say minus QTY, right? 10 was stored in the variable, so that's the appropriate way to do this, using my variables, not hard coding 10. All right, so another way that I can do this is by using a compound or combined assignment operator. And the way that it works, in this case here, since I want to be doing subtraction, I would say inventory minus equals QTY. Oops. And this is a shortcut for what I had just done. And this is essentially saying take inventory and subtract quantity from it and store the result back in the inventory. So the way that you read this, you say inventory minus equals quantity. So the net result is that inventory is going to be equal to 490. And if let's do a little see out here and just to see. So here, inventory equals inventory. All right, so if I run this, you should see that inventory is now going to be the 490. All right. So again, that's our shortcut. Let me go back over here to our textbook and let me show you the other compound or combined operators that we can use. So there's what, 1, 2, 3, 4. There's 6 of them. So we have addition, which would be plus equals, subtraction, which is minus equals, multiplication, which is star equals, division, which is / equals, and then the last one is modulus, which is percent equals. And let's look at an example here real quick. Here, if I say x plus equals 5, that is equivalent to it. That's the same thing as saying x is equal to itself plus 5. All right, pretty self-explanatory there. We just saw this one a minute ago with the minus equal. So if I say y minus equals 2, right, that's the same thing as saying y is equal to y or itself minus 2. Multiplication and division and modulus works the same. So that's how the combined assignment operators work in C++. I would become familiar with this because this is something that you're going to be doing over and over again, and it's a good idea to sort of write your code as efficient as possible, so you're not spending a lot of time, perhaps not only just typing, but perhaps creating syntactical or even logical errors with your long-handed results. All right, the next thing I want to cover from this chapter has to do with what's called formatting output. In this case here, the formatting of the output that we're going to do is going to be formatted to the console. But this is true whether or not we're formatting to the console or perhaps a file or what have you. Anyway, I'll to be honest with you, this is one of my least favorite things to do in C++. It's fairly labor intensive even to do some basic formatting, but once you kind of get the feel for it and you use it a bit, you'll see that it's not too daunting of a task to format output. So anyway, if you look at the screen that we have right up here, I changed, I put some code together here real quick, which is going to be something that's going to display like maybe some kind of pricing system, right? Maybe this is going to like dump some values out of a store system, right? That would display the price and the name for a bunch of items. By the way, too, I changed the name of my source file over here. I saw before that it said lesson like main2 or something like that, so I just called it lessons_main. So if you're wondering why this looks different over here, don't worry about it. I just didn't want it to cause any confusion for you guys. Anyway, so if we take a look at this example I have here, right, just a couple lines of code. So you see that on line 7, 8, and 9 right there, I declare and initialize 3 different items or 3 different products, whatever you want to think of them as. And each one of them are strings, and I'm assigning them a literal value: diapers, milk, or peanut butter. That's the idea. Down here on lines 11 through 13, this is where I'm going to store the corresponding values, okay, the monetary values for each one of those items, and I declared them as type doubles, and it's cost 1, cost 2, cost 3, and I initialize them each with some corresponding dummy values. Right, I'm using these for illustration purposes. Down here at the end, on line 16 through 18, this is where I'm going to display just the formatted output. So what I'm going to do is I'm literally just going to display the item, a space, and then the cost. And if I do that, you'll see that it's going to display in not such a clean format, because it literally just displays the item and then the cost, and the cost happens to go out quite a few decimal places in some cases. So what I want to do is show you how can we dress this up a little bit so things print out nice and neat in columns, and how we can force some type of decimal precision, and we'll use like the standard 2-digit decimal precision for like monetary kinds of values. So before we go ahead and do that, if you want to follow along, in this example here, you're going to need to include your IOStream library, the string library, and you're going to need to include one other library, and this is going to be used to access the formatting features of C++, and they're in a library or header file that's called IOmanip. Stands for IO input output manipulation. Again, this isn't just for the console. You could use this for any kind of input or output, such as a file, and we'll see this later on when we deal with files. All right, so now we know what the unformatted output looks like. Let's go ahead and let's create some formatted output. All right, formatted output. The first thing that I want to do is set the precision of my formatted output, meaning the numerical values that will be forced into Cout. Let me set with the precision, or how many decimal points that we're going to go. How far it will go out. So here I'm just going to say Cout and use the stream insertion operator. Okay, and we're going to call what's called a format specifier. In this case here, it's going to be called set precision, and I'm going to force it a value of 2. So that actually doesn't display anything to the screen, okay, the set precision format specifier on line 22. But what that will do is it'll tell cout from this point forward, anytime you come across a numerical value, treat it as with 2 decimal digits and round it to 2 decimal places. So in this example here, 105.371 will be equal to 105.37. 9 will be equal to 9.00, and 64.9384, that will evaluate to 64.94 because the 3 will be rounded up to 4, right? Because that's the standard rounding mechanism. So that's how you can set the precision of floating point values. Next thing I want to do is show you how we can create columns, right? So typically, if you have some kind of output, you want to have everything kind of line up. In this case here, we're going to have essentially 2 columns, one column for item, and the other column for the cost. Let me create like a little table header here, which will make things a little bit simpler for us, just to dress it up a little bit. So here I'm going to say cout again. And I'm going to, again, give it another format specifier, and this one is called set W, standing for set width. In this case here, I'm going to set the width to be, I don't know, I'm going to make it 15. So anything that's going to fit in the first column, okay, will be 15 characters wide. And what am I going to put into the first column? I'm just going to give this a header that's called item. All right, because this is where I'm going to put my items. The next thing I'm going to do is to create another column for column 2. Let me do that. So let's do this here. And here I'm going to say set W, and we're going to call this, we'll give this a size of, let's make this one a little bit smaller since we're only dealing with numerical values here. Let's just make this one of size 10. And what we're going to shove into this column is going to be the string cost. And then end L. So that's how we can specify what the field width is of those items. The default behavior of the formatting within columns in C++ is that I believe everything will be right justified. I'll show you in a minute how we go ahead and we can override that. And let's step forward a little bit here. So let me create like a little formatted line underneath our header. So you can think of line 23 as being like the header, or sort of like the title for our output. Let's go ahead and put like a little dashed line in there. And what I'm going to do is just I'm just going to count along here. So I'm going to make this 15 dashes. So there's actually a shortcut on how to do that, and I'll show you guys that maybe later on. So the first column will be 15 little dashes, and the next one will be 10. And then let me just feed it the end L again, operator. And now what I want to do is I want to go ahead and specify or show each one of the items that are part of my output here, and list them out into the multiple rows and the 2 columns. So here I'm going to say cout once again, and in this case here, what I want to do is I want the values here to be left justified. So there's a format specifier that's called left that will, once fed into cout, will tell us that the next thing that's going to be displayed within cout will be left justified. But before we go ahead and actually feed it anything, we need to set the width of this column, okay, which will be 15 characters once again. Then we'll do our next column. In this case here, what I want to do is, actually I need to feed it the item. So I'm going to feed it item 1, right? So that will be item 1. Forgot my double brackets, double insertion operator. So everything that you see here that I'm highlighting, this is essentially setting up the format of column one. So there's quite a bit of work just to set up one column, and it's quite tedious to do in C++. Let's do column two. In this case here, what we'll do is let's make this column right justified. What I'm typing here, the words left and the words right, they're actually not they're not keywords within C++. Okay, these are part of the IOmanip library, so that's why they're not appearing in blue, just so you know. Okay, these are what are called string manipulators. So let's make this column right justified. Let's set the width to be 20. I forgot my insertion operator again. Set it to be 20, and then let's do the let's output. So we have item 1, right, and then we'll do cost 1. And then we'll do my little endl, and now we're done. So that will display row 1 nice and clean. What I should do is I should also specify up here that this is going to be left aligned, so I'll make this left also. 15, and let me make this guy over here. Let's make this right aligned, just for consistency purposes. All right. And that should work. But before I go ahead and continue and do the item 2 and item 3 and cost 2 and cost 3, I want to point out to you that this is a perfect example where what you want to do is not hard code values. What I mean by that is you don't want to hard code the value 2. Okay, you don't want to hard code the number 15 and the number 10. Oh, actually, this should be 10 over here also. I'm sorry, that's a typo. I shouldn't be hard coding these values. The reason is because you might have some fairly sophisticated output, and what happens if you need to change that output at a later date, you have to go through your program and make those changes in most likely quite a few different places. So the idea is that if you change these literal values here, these numerical literals to constants, it's going to make your life a lot easier later if you need to make any changes. So let's do this one. I'm going to declare my constants up here at the top. So I'll do const int, and I'll just call this precision. I'll just call this DEC for like decimal, and we're going to make it 2 decimal places. And then we'll create another constant for let's call this col1, and I'm going to make this, 15 characters, and I'll make another one const int col_2, and that's equal to 10 characters. Now what I'm going to do is I'm going to use those constants a little bit further down in my code, and if I ever need to make changes to the decimal precision or the width of either column 1 or column 2 or column n, I only need to do it in one spot. That's the idea. Again, just so you know, when I declare a constant, okay, I must initialize the constant at that time with a value. So when I say constant DEC, I need to assign it a value. In this case here, I'm assigning it to value 2. You'll also notice too that I declared the constants in uppercase. That's not required. However, you'll see that that's essentially a convention that's been adopted for forever. And that's why that is being used. So while it's not required, it's again, it's sort of a convention that's been adopted, and since C++ is case sensitive, if I declare this is uppercase here, I need to use uppercase down below. So here what I'm doing is I'm going to set my precision to be the constant for decimal. This guy here is going to be column 1. This guy down here is going to be column 1. This one over here will be col2, and this one down here will be also col2. And that should do it. Before I would do the remaining items and the remaining cost, let me go ahead and build this and run it, and let's see how this looks. I don't have any errors. I had to minimize my window here so you can see this. I have no errors. the constant is, all right, so the diapers is looking right. For some reason, the this value here for the cost is displaying rather strange. I'm not sure why it's showing up in scientific notation. Let me try one other thing here quick, and let's make this fixed. Explain this in a second. This should probably fix it. Yeah, that fixes it. All right. So there's another stream manipulator that's called fixed, which, gosh, I think this is compiler specific, but I guess with Visual Studio here you need to use the fixed manipulator, which means that it will show your number in like standard base 10 decimal precision. The idea is that once you set the precision, like you see here on line 26, and you set the stream manipulator fixed to show the decimal places in your standard base 10 format. Once you do that, that will be set until you make another change with the set precision or fixed manipulator. What I mean by that is you don't need to do that for on every line of your output, unlike the set W or set with stream manipulator. All right, let's go ahead and copy this down. We'll do for the next two, and then we'll take a look at the output. So if I do this, copy it down twice, what do I need to do? And then you change item 1 obviously to item 2, and cost 2, and then this will be cost 3, and item 3. Now when I do this, you'll see, let me put just to dress this up a little bit. Let me just put another blank line in here for you guys just to kind of break up the screen, might make it a little bit easier for you to see. When I go and I run this again, you'll see the first couple of lines of my output, which is what you see here, right, has everything just displayed in an unformatted format. Down below, right, I have everything lined up as sort of, essentially columns and rows. So everything within column 1, which is where all my items are listed, will fit within the 15 character limit that I specified. If I created something here that was larger, it would just overflow into the next column, which probably isn't what you would want to do. So you got to be cognizant of the fact is how large you want to make your column. The things that we're doing in this course, you don't need to worry about the format all too much. The second column, which is cost, you'll also notice that it is set up to fit within 10 characters, and it is also, right justifies, and we're also displaying the values in 2 decimal precision. So in summary, that high level, that's how you can do formatting in C++. There are some more details that are used with formatting output. We could spend a lot of time on this. I don't want to spend too much time because we're going to, first of all, we need to cover a bunch of other things this week. And second of all, we kind of start to get into some of the more advanced things, which were typically covered in the second half of this course. So if you can, I would suggest, if you want, pause here, try an example doing both formatted and unformatted output. What happens if I change my manipulators here from left to right, or what happens if I just get rid of the left and right, because those are essentially optional, and see what the default behavior is. Try something like this. Go back to your constants. Okay, change column 1 to be a width of just 5. Right? If I make it just 5, well then I clearly can't fit the word diapers or peanut butter within 5 characters. But see what happens. Do the same thing with column 2. Change column 2 to be something where you can't fit the values. Make it just size 2, and then then make it size 50. See what happens. Play around with this. Right? You can play around with this example a little bit, and I think once you do that and you maybe break things a couple times, you'll get a better feel for how to do formatting in C++. All right, the next thing we're going to cover is section 3.8 from your book, and this has to do with how to capture strings from keyboard input. And we saw in previous examples that reading a string from the keyboard, via console input in the keyboard is pretty straightforward. except under the condition where you may have white space within a string. And a classic example is, you have a prompt that says, please enter your name. Well, your name may be separated by a space right between your first name and last name, and the default behavior of the CN object won't work as expected. So let's take a look at an example, and I'll show you how we can go ahead and fix that. So let's say I have I'm just going to create a variable here. It's going to be of type string. And it's going to call it name. All right, that works. Am I including the string library? Yes. String name. And here we're just going to have a little prompt. We want to capture, the person's name. Please enter your name, or we'll call it your full name, right? Implying first and last. Notice no end out here, so please enter your full name. Then we're going to say CN. All right, we're going to extract that from the CN stream, and we're going to store that in name. Now we'll just display or echo out what the person entered. Let's say your name is, let's say your full name, to be consistent, full name is name, and in here we'll use NL. Alright, so line 7 we just declare the variable name, which is a type string. Line 8 we just display a prompt to enter somebody's name. Line 9 we actually capture the name from the keyboard, and then on line 10 we display or echo back what the person entered. So let's run this and let's see what happens. We'll run this under two conditions. The first one is the simple case. So let's say my full name is just Chris. No, let's make it something small. Let's do Bob Smith. All right. So there I concatenated. There I can Bob. Excuse me. S. So there's the name Bob Smith. And says your full name is Bob Smith. Okay, well that works as expected, and the reason is because I don't have any white space in my name, right? It's just Bob with Smith concatenated together. That's not typically the case, right? Normally what we do is somebody wants to enter their name, or if you're reading in a name from a file or a web server or something like that, more importantly, it might come over something like this. It would say Bob Smith. Then it says your full name is Bob. So the problem here is when it says your full name is Bob, even though I entered Bob Smith, the default behavior of the CN object that it'll read Bob, once it comes across the very first new white space character, whether it's a space or a tab or the new line character, it ignores it. However, there's a simple way to get around that, and there's some functions built into the string library header file, which will allow us to get full strings into our program. And the way that we do that is we're going to change the way that we do this part here, how we capture the input from the user. So now instead of using CN directly, what we're going to do is we're going to call a function that is part of the string library, which is inside the pound include string. And the name of that function is called getLine, and that getLine function takes two parameters, and I'll show you what they look like in a second. So I'm going to say getLine. So this is the name of my function, and it's expecting two parameters. The first one is going to be what is the stream that you want to read from. In this case here, we're going to be reading in from the console input or CN. The second parameter is going to be where do you want me to store the result. In this case here, we're going to store the result in a local variable that's called name. So what getLine will do for us, it will read an entire line, or think of it as an entire string, with white space characters in there, and it'll read the entire string up to but not including the new line character. So whatever you type up to but not including the enter key will be captured within the variable that's called name. So now if I run this again, you'll see that we're going to get a different behavior, and I'll walk you through this how this works. Let's do Bob again. Bob Smith. And now it says your full name is Bob Smith. So what's happening here is that on line number 9, the difference is once we get to this, so line number 8 is a prompt. Line number line we call the function that's called getLine, which is part of the standard string library reference. We pass in cin, and we pass in a local string variable that's called name. Once this function is done executing, once the getLine function is done executing, it is going to store the result in the argument that we pass to it, which is called name. I'm kind of jumping ahead here, but what's happening here is the variable name is being what's called passed by reference. So whatever getLine does to the variable that's called name, those changes are visible outside of the calling function, in which case here getLine. So name then is populated with the value, and then we can display what the name is down below. So that's how you can. That's how you should use. That's how you should capture string input for anything that's could potentially contain a white space character in there. So make a note of this because you're going to be using this throughout the semester for a lot of your other labs. I'm pretty sure you have to do something like this on a midterm. Is that true? I think you have to do something like this on a midterm. If not, most certainly the final lab will have you do something like this. So that's how we can capture strings. Now I'm going to show you something which is a little bit easier, a little bit more intuitive. And that's going to be how do we capture characters. The reason I want to show you this is because later on in the course, you're going to be creating like little menuing systems. So that a menuing system is going to be something like you're going to display something, and if the user chooses selection 1, you're going to perform some action. If they choose option 2, they perform another action. If they perform option 3 or select option 3, they're going to perform a different action. Finally, if they hit Q or X or something like that, they're going to quit out of the program. So let's pretend we create like a little menu here. We're going to see this a little bit more later on, but let's say I'm going to create a local variable char, and I'm going to call this selection. All right. Here I'm going to say, let's create a little menu here. I'm going to say cout. Please enter a selection. Please enter a selection. Here what I'll do is let me do. Actually, let's put please enter a selection at the bottom. Let's do something like this. Cout. I don't know. What are we doing here? Let's say M. I'm just making something up here. M. We're going to. So if they select M, this is going to be multiply. Multiply. I don't know, I'm just making something up. Multiply. I do cout a add cout. I think you get the idea, right? S subtract. Again, this is just a little menu. And then finally, you do something like this, say cout, I don't know. Let's do Q for quit. And the idea is that you see this menu, and if you have the choice to either select M, A, S, or Q, and depending upon which one you select, maybe there'll be further prompts, and you say, okay, please enter the 2 numbers that you want to multiply or add or subtract, and if you hit Q, then you terminate the program. That's the idea. So what we want to do is let's get rid of this here. Let's get rid of my endl here. So now what I want to do is let me capture what the user inputs. I'll say cin to selection. And here I'll just say, all right, cout, you selected option, you selected menu option selection. And typically what you would do is we would have this in a loop, and we're going to talk more about loops in 2 chapters from now. And the idea is that you would just keep prompting the user with this menu until they hit Q. So you could do multiple multiplications or additions or subtractions. That's the idea. So let's build this. Let's run it. Let's see how this works. This isn't in a loop, so we're just going to see it once, and then we're going to have to quit. Please enter a selection. So my program doesn't really do anything here. So if I just type M, I should put a colon in there or something. If I just type M, it's just going to say that you selected menu option M, right? And actually, it is going to quit anyway, right? Because I didn't put any other logic in there. So if I run this again, and let's say I type, I don't know, X. All right, just says you selected menu option X, right? Maybe what we would want to do is be able to say, invalid option, please try again, or something like that. So you get the idea. So the key part here is to understand that we learned how to capture numeric values before, like integers and doubles and those types of things. Now you know how to capture strings, and now you know how to capture characters, and we'll be using this in the future. I think actually one of the labs will have you do this for this week. All right, that's it for this section. All right, next thing I want to cover, guys, is another math library function. There's a whole bunch of mathematical library functions that you may use at some point in time. The one that I want to cover today is how do we create random numbers. We actually saw a mathematical function earlier on. That was that power function, POW, which is used to take a number to a particular power. That one's very common. That's one that you'll use throughout the semester for other assignments. But what I want to do today is talk about how to generate random numbers in C++. There's a little table on page 125 in your book which lists some of the other mathematical library functions that we have access to. But we're going to just focus on a random number generator for this lesson or for today. All right, so random numbers. What are random numbers used for? Actually used for quite a few things within programming and computers in general. One of the most common things that they're used for is for like gaming. Okay, if you have a game and you want to perform some type of simulation, a lot of times behind the scenes there's some kind of random number generation that's going on. They're used all over the place for like statistical programs and those types of things. And another place where random numbers are used all the time is within computer security. And the way that works is, if you go to a website that has a URL, https:// something, blah blah blah. The whole notion of public-private key encryption is based upon how we generate random numbers in computers, not necessarily within C++ or even on a PC. So without random numbers, we wouldn't be able to have what's called public-private key encryption, and that's a way for us to anonymously send encrypted data back and forth between let's say your browser and your bank's web server. That's a general idea. So anyway, enough about random numbers and what they're used for. Let's go ahead and see how we can create a random number within our computer. So in order to generate random numbers in our computer, and by the way, I was going to tell you right now, within C++, it's a little bit less straightforward than some other languages. You actually this is sort of like a multi-step process in order to generate random numbers properly. But nonetheless, first thing that we need to do is we need to include the header file here, which is called CSTDLIB, which just stands for the C Standard Library. And that will give us access to the function that we need to call, which is called rand. So random numbers are going to be returned as integers. So let me create a local variable here that's going to be of type int. And I'm just going to call it R for my random number. And I'm going to declare it here, and I'm going to initialize it on the next line. So here I'm going to say R is equal to, and I'm going to invoke a function which is called rand, open and closing parentheses, and that's the end of my function call. So once this function here, rand, is done executing, its return value will be assigned to my local variable here that's called R. let's display what my random number looks like. So I'll say cout, my random num equals R. Now when I no compiler errors here, if I build this and run this, let's see what my random number is. So I execute this and it says my random number is 41. Okay, that works. Let me terminate my program. Let me run this again. And I get my random number is 41 again. Now that's kind of weird. How could I get that 2 times in a row? That seems a little strange, right? If I run this again, I get back to a random number 41. If I keep doing this over and over again, I'm going to keep getting the same number and over and over again. The reason is because there's an extra step that we need to take in order to successfully truly create random numbers, and that is that we need to do what's called seeding of the random number generator. So seeding means basically initializing the random number generator that's processing behind the scenes. Once we seed the random number generator, then we'll truly get back some pseudo-random numbers from that point forward. So anyway, that being said, what we need to do is we need to call another function here that's called srand. And actually what we're going to do is we're going to seed this with the time on our computer. So we need to include one other header file here, asking the pound include, and this guy here is going to be called ctime, ctime. All right. So what we're going to do is we're going to seed the random number generator with the current time on our computer, which is something that's going to change, right? As you execute the random number generator now, or if you do it in 100 milliseconds from now, the time on your computer will have changed, and by doing that, we'll be seeding it with a different value, which will then generate or should generate a distinct or another random number for us. So here's the first step that we're going to do. The first step is that we need to go ahead and capture what the time is on our current machine. And again, this is operating system independent. So if you're doing this on a PC or a Mac or a Unix server, it will function the same. Here we need to create a local variable that's going to be, it's an unsigned integer, so I'm going to say unsigned int, and we're going to assign it, and we're going to call a function that we're going to call the time function, and the time function will capture the current time. I believe this is like the current time in, I don't know, it's either seconds or milliseconds since like January 1, 1970. I'm not sure if it's seconds or milliseconds. Actually, it really doesn't matter. But there's some starting point, which is January 1970. I think they've explained it in the book too. But this will capture the current time. So the function takes the one parameter. I'm going to pass it the argument 0. Okay, just initialize it to the default. And now I have my. I forgot to use a variable name. I'm just going to call this unsigned int. I don't know. I don't want to call it time, but I'll call it now. Right? So I have a local variable that's called now, and I'm going to assign it the current time on my machine. The next thing I need to do is then seed my random number generator with the current time, which is called now. And that function, which is in the C standard library, so we're already including it, which is good. It's called srand, S-R-A-N-D. And here I need to pass it a seed, okay, and my seed is going to be my argument now. So I'm going to feed it my argument now, which is the current time. I'm going to then initialize a variable R with my execution of my random number generation. And now I should truly get back some truly random numbers, or actually what are called pseudo-random numbers. Let me check out this warning here real quick. Unsigned int, possible loss of data. It's a different structure. That's fine. For what we're doing now, if we just use this as an unsigned int, that's fine. Even if you're using a different compiler, it should be able to you'll get past this warning. Now, when I run my program, I'm going to get some truly pseudo random numbers. I just mentioned this a second ago. Just so you know, computers, and this isn't just a C or C++ thing, computers actually are not very good at generating random numbers, which is you might think is kind of non-intuitive because all computers do is calculate and perform calculations all the time. But computers are what are called stateful machines. So which means that they are not so great at generating random numbers, and typically when you're in the computer science world, you typically refer to random numbers as what are called pseudo random numbers because of the way that they are generated are not truly random, and they're dependent upon some type of input. So anyway, nonetheless, if I run this now, let's see what we get back. So I get back to number 852. If I run this again, I get 865. I get 871. 878, 891. So I'm getting back some different numbers. Not quite sure why they're all in the 800 range. Maybe it has to do with the way that I'm invoking the time function, but nonetheless they are they've been unique throughout this time. There we go. We get 953, 963. Let me show you what we could do if let's say we wanted to create a random number that was between 0 and let's say 100. Okay, between 0 and 100. What happens is rand itself is going to return an integer. And the integer could be fairly large because integers can get big. But what I could do is I could change the range of values within my random number generator within a range by using a modulus operator. That's what I'm trying to say. So here I could say R is equal to R mod, let's say 100. And if I do that, remember when you do modulus, that gives you back the remainder, right? So this would give me back something in a range of 0 to 99. And that's one way that we could do this. Since we just talked about this earlier, I want to show you that we could do R mod equals. Okay, now this you don't typically see so much, but this is one way that we could do this. Now if I run my program here, you'll see that I'm going to get something back in a range of 0 to 99 inclusively. So I won't include 100, or it shouldn't include 100. Whoops, it shouldn't include 100, but it should include 0 to 99. So anyway, play around with this. Changes from 100 to 1,000, change it to 10, make it 50, whatever you want to do, and that shows you how we can create values within a range. Also, again, we're going to use random numbers throughout the semester, so go ahead and here and change sran to be, instead of now, just hard code the value 20 in there or something like that, and see what happens. So you play around with this and see how what the behavior is that you get, that covers random numbers. So that's it for the for chapter 3. What I want to do next is, I know we're kind of going a little bit long here, but I want to cover at least like the first section or two in chapter 4. This way next week for our next lesson I'll be able to complete the rest of the items in chapter 4. So again, I apologize, this one's going to be a little bit long, but we're covering a lot of material here. All right, this is the beginning of chapter 4, and this chapter has to do with all the different types of most of the different types of decision branches that we can make. The very first part that we're going to deal with is covering what are called relational operators. So the idea is that in any typical program, what happens is based upon particular conditions, your program will take one path of execution or another, and that's how you can logically create the flow of your program. The foundation for conditional branching is all based upon the different relational operators that we can make use of. So the idea is something like this. If a student gets a grade that's greater than 70, then they take the branch where they pass and they get credit for the course. Otherwise, your program would take a different branch and it would get a a failing grade and they don't get credit for the course, something like that. So based upon a condition, your program will execute something and not something else. So on page, I guess it's like 150 in your book, I think it's the same online. These are the 1, 2, 3, 4, 5, 6. These are the 6 different operators that we can use in C++, and we can use these for numeric types, character types, and also the string type. We'll see more about the string type later, but we're going to stick with the basics like numeric and character types now. And they're pretty self-explanatory. These are things that you've seen in math before, right? So if you have 2 operands and you have the relational operator greater than in between them, it'll check to see if one operand is greater than the other. Here, this is less than. This guy here is if you want to check if something is greater than or equal to another value. This is less than or equal to another value. This guy here, this the one with the double equal sign. This is how we actually test for. This is how we actually test for equality, meaning like are 2 things equal. This is different than a single equal sign, which is the assignment operator, and I'll show you that in a second. And then the last one is the not equal to operator, and this is how we can check to see if 2 things are not equal to one another. So let's go through and take a look at a little example and see how this works. And the other thing too I want to mention here, I'm not sure if it specifies it in the book. It probably says it here somewhere around on this page. I would take a read through this if you have a chance. But the idea is that this operator, along with its 2 operands, will be an expression, and the evaluation of that expression will be some type of what's called a Boolean result, meaning either true or false. So the output of a relational operation is something that's either true or false. So let's go ahead and let's do a little example over here. So let me create a couple of little local variables, and we'll see how we can do this. So I'll create a variable here, int x is equal to 5 and y is equal to 6 or something. And so those are going to be the 2 operands I'm going to be using in a minute. And let's create another local variable here. And we'll use this, we'll just call this bool, we'll just call it result. So let's do a little simple relational operation here, and let's say that result is going to be assigned the evaluation of the expression x is less than y. Well, what do you think the answer is going to be here? Well, if x is equal to 5 and y is equal to 6, is x less than y? Yes, it is. So the result that's going to be, the value that's going to be stored in result is going to be the value for true, because that's a true expression. So let's display that. Result equals, I'm going to use this over a couple times. So let's try this and let's see what the result is that we get back. So if I execute this, here it tells me that the result is equal to 1. In C++, which is a little bit different than like Java if you ever took a course in that, any kind of Boolean expression can be resulted in a numerical value. And the rule is in C++, any value that evaluates to true, any value that evaluates to 0 is false, anything else is true. The typical notion is that false is equal to 0 and true is equal to 1, but true could also be equal to 2 or 3 or 4 or 5. It's anything other than 0, so it's like 0 or not 0, right, if you want to think about it that way. All right, so this obviously is equal to true. What if I switch my relational operator and try something like this? Is x greater than or equal to y? Well, in this case here, that's clearly false. Okay, so let's run that and let's see what the result is that we get. And now we find out the result is equal to 0, and we're at 0, which indicates false. Okay. So less than or greater than are pretty straightforward. What if I want to see if x and y are in fact equivalent? Well, that's when I would use the double equal sign. Okay, the double equal sign is the equality operator, which is different than the single equal sign. So don't get them confused. Okay, a lot of students get these guys confused. In other languages like Java, the compiler will catch these types of not syntax errors. Well, actually, yeah, in Java, it would catch these types of errors. In C++, if I did something like this, okay, it will compile, okay, and in this case here, result will always be equal to true. Why? Because we're assigning the value of y to x, so we're taking 6 and storing it in x, and then we're taking 6 and storing it in result, which evaluates the true, because that would mean that, let's just compile it. Let's see what happens here. We get a little warning. That's fine. This is not something you really should do anyway. So here it's telling me that my result is equal to 1, and that is because it's just evaluating it as being true. So y is being assigned x, and then x is being assigned to result. So anyway, you don't want to do something like this. This evaluates it true, but we're not getting the answer that we really want. What we want to do is we're trying to do something like this, where I'm saying, is x in fact equal to y? In this case here, it's not, right? Because if x is equal to 5 and y is equal to 6, well then 5 and 6 aren't equal. So the result of this expression, right, x and y are the operands, the double equal sign is the operator. The result of this expression is in fact 0 or false. Let's change this to be the last relational operator, which is not equal to. In this case here, it's saying, okay, is x not equal to y? Well, yeah, if x is x is 5 and y is 6. Well, 5 and 6 aren't equivalent. So in this case here, the result would actually be true. And if I run this, I get back to result 1, which stands for true. So that's the entire foundation for how we can create conditional branching and conditional logic within our programs. And we'll be using these relational operators all throughout the semester. And if you're familiar with Java, the syntax is very, very similar for conditional branching and conditional logic. All right, let's take a look at how we can create branches in our program. This is really the first time that we're going to see something within our program where we're executing code conditionally. Right? So the idea is that our program will take a pause or an alternative branch depending upon the value of some expression. So let's use a scenario that I mentioned before about students and their grades. So let me kill this. So let me create a little local variable here, bool pass, and I'm going to assign that equal to false. So the idea is that at the end of the course or the test or whatever it is, your student gets a passing grade or a non-passing grade. And here let's create another local variable int grade. All right, and let's assign that to, let's make it an 80 or something. And what I can do here is I can specify. I'm going to use an if statement. This is the first time that we've seen this. Okay, and an if statement will allow us to conditionally execute a piece or pieces of code. And the syntax for an if statement is pretty straightforward. Let me show you the example or the details from the book, and I think it's on page 1. This is actually a good little example here. Okay. If statement where it is here. So there's multiple ways that we can create this, what are called decision structures or conditional branches in our program, and if statement is just one of them. And the syntax works like this. We can say if expression statement. And this means that if expression is equal to true, then execute this statement. If expression is equal to false, don't execute this statement. And it's nothing more than that. I mean, it's pretty simple. You just need to make sure that you create a valid expression. So let's go back to our coding example here, and I'm going to say if grade is greater than, let's say, 70, again, it's probably a good place to use a constant, then I'm going to say pass is equal to true. So depending upon the value of grade, if it's in fact greater than 70, they get a passing grade. If it's not greater than 70, right, meaning that it's less than 70, then we won't change the value of pass, and pass will, which what we're doing on line 8, we won't change the value of pass, and it will remain false. So now I can say cout, right, or create a report card, whatever it is that you're doing, and we'll just say pass is equal to, now let's think about what pass should be equal to here. In this case here, grade is equal to 80. Is 80 greater than 70? Yes, it is. So we should assign true to pass. And now when we do our cout, pass should be equal to 1, which is true. So if I run this, we say pass is equal to 1. Good. Now what happens? What if I change my grade to be, now I'm going to make my grade, I'm going to make it, make it 69. So now my grade is not greater than 70. So this code on line 12 will not execute. So the way this works is that if this expression is true, then the next statement will be executed. If this expression is not true, then this expression will not execute. So since my grade is equal to 69 now, this will evaluate the false, and this expression here on line 12 will not be executed. So we will not change the value of pass, which we initialized to false. So if I build this, I just did, if I execute this, now we can see that pass is equal to 0. So since I said the grade has to be greater than 70, well, if the student gets a grade of 70, right? In this example here, again, this is not really like in true life. So if the student actually gets a grade of 70, they would actually get a failing grade. Why? Because I'm saying that the grade has to be greater than 70. In this case here, the grade is equal to 70, so it's not quite greater than. So we would still get a failing grade. So if I execute this again, I still say that pass is equal to 0. All right. Here you have to be careful. And let me go back to the textbook, and I have a good little explanation in here. Here we go. I would read through this section. It's really important that you understand how if statements work, because they're going to be used a lot in any programming language that you use. So here, this highlight here says, "Be careful with semicolons." All right, what that means is, in C++, when you have if and then you have your open and closing parentheses and your expression in between, do not put a semicolon after your expression here, after the closing parenthesis. All right, the semicolon is going to go after your statement. The problem is the way that the if statement works. Not the problem. It's just that the way that the rules are set up is that the if statement, okay, will evaluate if the expression is equal to true within the if statement, the very next statement that follows it will be evaluated if the expression is true. So if I were to put a semicolon here after my closing parenthesis here, that would tell me that if expression is equal to true, the very next thing that would be executed would be the statement, which in this case here, it would just be that blank semicolon. That blank semicolon is what's called a null statement or an empty statement, and it essentially doesn't do anything. So sometimes programmers will use those types of things as placeholders within your program, but they can create like really, really difficult bugs for you to find if you put a semicolon after your if statement. Syntactically, it's correct, but logically, it's probably not what you want to do. So just remember that it's the semicolon that's after your if expression is the one that's going to be paired with that if expression. So let me let's try an example here, and I think that'll help illustrate what it is I'm talking about. All right. All right. So let me give this person a clearly failing grade. So I'm going to give them a grade of 50. All right. So it's clearly a failing grade. And now I'm going to say, okay, if grade is greater than 70, and now what I'm going to do is I'm going to inadvertently put a semicolon here. the compiler will let me do that, but that's going to be that semicolon is going to be the thing that's going to be evaluated if the grade is greater than 70. So in this case here, what's the value of grade? Well, the grade is equal to 50, right? So is 50 greater than 70? No. So this won't be evaluated. However, this statement down here is not paired with this if statement, so I will unconditionally assign true to the variable pass. And if I do that, here it gives you a warning, which is kind of cool, but it still allows you to do that, and it's just telling you it's telling you it's an empty control statement. Is this the intent? So this is cool that the compiler catches this. Not all compilers will do that. And in this case here, it's not what I really want to do, but I want to illustrate this as an example for you guys. So imagine, so again, the idea here is that we don't want pass to be equal to true, but it is going to be because I put that null statement here. So now you can see that pass is equal to, in fact, 1. So be very, very cautious of that. Alrighty. Let me go back to the example I had before where I had the variables x and y, and let me show you another problem that you might come across if you use the assignment operator instead of the equality relational operator. So what it had, int x is equal to 5 and y is equal to 6, right? And something like that. And here what I'm going to do is I'm going to say if x is equal to y, I'm going to say cout x and y are equal. Just so you can see that the program is actually doing something, because this cout statement won't be executed. Why? Because x and y aren't equivalent. Here I'm just going to say done or something, just so you can know that the program actually is executing. All right. So on line 10, that's where I'm going to use my equality relational operator to see if x and y are actually equivalent. In this case here, they're not, right? X and y are not the same values. So that statement on line 11 will not execute. However, the statement on line 13 will execute, because that's just telling me that my program is complete, or that it did something. So let's run this, and we should just get back done. Okay, good. If you make the mistake of using the assignment operator as opposed to the equality operator, you're going to get an unexpected result here. Remember that in C++, anything that is other than 0 is considered to be true. 0 is considered to be false. So let's think about this expression I have with my if statement here. I'm saying that if, and I'm saying x equals y. Right here, I'm assigning y to x, so y is equal to 6. I'm assigning 6 to x, so the evaluation of that expression is going to be 5. So essentially I'm saying if 5, what is 5? 5 is not 0, which means that it's true. Okay, 5 is going to evaluate to true. And then this statement down here, x and y are equal, is going to execute because of the mistake that I made with the single operator. I'm sorry, the single assignment operator. So this is clearly a logical bug in my program, and this is something that many students will do. I've done this. I'll still do this myself every once in a while, because you forget to type the double equal sign. The problem is the compiler will allow you to do this. If you try to do this something like this in Java, it'll generate a compiler error, and you'll know that you have an error. So this is it could be a pretty nasty bug in your program. So be very careful of this. And just again, I can't emphasize enough to understand the difference between the single equal sign, which is the assignment operator, and a double equal sign, which is a logical equality operator. All right, oftentimes what happens, you have an if statement, but you want to have multiple items paired with or attached to that expression. Now, the idea is that you might want to have a bunch of things execute based upon the value of an expression, as opposed to just one statement. So fortunately, C++ and most other languages have the ability for you to pair multiple statements with one expression. The way that we do that in C++, we just use a pair of curly braces to create what's called a block statement. And the way that it works is that the syntax is all the same. So we say if expression, again, paired within a set of open and closing parentheses. And then what you do is you have a block of code that begins with a curly brace and then finally a closing curly brace. And whatever stuff, okay, whatever statements you put in between the pair of open and closing curly braces will be executed if expression is true, and it won't be executed if expression is false. So this is extremely common. So when you have multiple statements, this is the way that you can do this. It definitely shortens your code by doing this. This open curly brace doesn't need to be on the line below the if statement. You could put the curly brace right after your expression if you want, and that's fairly common. So again, it's just a matter of format. Again, that's just white space. Remember, your compiler ignores white space. So let's go back to our program here and let's create a little example. And I'll do something like this. All right, so let's do bool pass. Go back to this example here. Bool pass is equal to false. Int grade is equal to 80, and int credits is equal to 0, and we'll keep it like that. That's good. So the idea is that if you pass the class, if you get a grade greater than 70, then you pass the class and you get 3 credits or something like that. That's the idea. So that there's more than one thing is going to happen if you get a good grade. That's the idea. You know what? Let's unlike I did in the previous example, this is a good place to use constant. So let's say const pass grade, and let's do this. Let's make your passing grade. Let's make it 70. Right, let's make your passing grade 70. So int passing grade is equal to 70. So as long as you get a grade greater than 70, you're going to have a couple things happen. So what we can do is let's create a little program then here. A little if statement which is going to test that. Again, here is a good place to use a constant. I probably should have done that in the previous example, but I'm just trying to get through this a little bit quicker. All right, so here I'm going to say if, all right, if grade, all right, meaning your grade is greater than or equal to 70. So let's assume 70 is a passing grade. Okay, so as long as it's greater than or equal to passing grade. Okay, then what we're going to do is we're going to have a block statement. So this is going to be the beginning of my block statement. So here's my open curly brace. Now again, if you highlight this thing, right, there's my open curly brace. There's my closing curly brace. Play around with the IDE, and you'll see that depending upon where your cursor is, it will highlight the matching curly brace within your program. This is extremely useful because what happens is if you might have multiple lines of code with like nested if statements, and you're trying to figure out which curly brace is paired with which. And this is extremely useful if you can just select or put your cursor in the right spot. You might not be able to see it on my screen, but if you try it on yours, you'll see how you can determine where your curly braces are paired. All right, so grade is greater than equal to passing grade. We'll just do something like this. We'll just say, okay, we're going to give you credits is going to equal to 3, meaning that you get 3 credits for the course, and then you get a little cout here that says, congratulations, you passed, something like that. So if I got my semicolon, congratulations, you passed. And then here I'm just going to say cout, done. All right, just so you can see that, done, something executed. All right, done. All right, so you passed. You know, let's do this too. Let's just say you passed. Let's do this. Let me change it. Say congratulations, you passed. And down here, I'm going to say is, let's try to cheat here. Credits equal credits. Because I want to run this again in a minute when we have a non-passing grade. So the first time around, since the student didn't get a passing grade, they'll get 3 credits and they'll get that little C out, and then you'll see how many credits there are. Next time I'll do is I'll change it to a non-passing grade, and you'll see you get a different flow of control. So this block of code here, right, the code on lines 14 and 15, will only execute if this expression is true. It's as simple as that. All right. So if I run this, you should see that you get congratulations, you passed. I forgot my endl. It says credits is equal to 3. So let me clean this up. So congratulations, you passed. Credits equal 3. Done. And I forgot another endl. Credits equal 3 credits. Sorry. I'm rushing so we can kind of shorten this. All right, so there they get 3 credits. So there's a block of code. Now let's give the student a failing grade. Again, remember, imagine that these grades are being fed in from like some database somewhere, right? And you're not hard coding these things into your program, but you get the idea, right? So not 600 but 60. So if I run this again now, since their grade is not a passing grade, lines 14 and 15 of my program will not execute. So we won't assign 3 to credits. We will not display the congratulations you passed message. However, we'll still execute lines 18 and 19 just as we did before, because this is outside of the block of code paired with the if statement. So the credits in this case here will be equal to 0, and then we'll just say that the program is done. So credits is equal to 0, and it's done. That's it. Obviously, we could probably dress this up to be a little bit prettier, a little bit nicer, a little more user friendly. And that's the end of this section. But we'll see how to do that once we learn how to use if else and what's called if else if statements, and then we can also use what's called a switch statement. Once we cover that, we'll be done with this chapter. So that's it for this week. I know this went a little long. Actually, it went quite long. I promise the next lesson won't be as long because we'll be able to wrap this stuff quite a bit quicker. So that's it. Have a good week.